Good morning. I am Sanghavi from CSCA. My project is towards LLM assisted vulnerability detection and repair. It is used for strengthening open source 5G user equipment implementations through chain of thought prompting and secure coding practices. And core methodology of our project is COT prompting and 5G properties and secure coding. COT prompting, leveraging the chain of thought reasoning to guide LLMs through structured analytical steps for complex semantic vulnerability identification. And 5G properties, utilizing curated 5G vulnerability properties structured around remote exploitable inputs through RRC and NES and protocol integrations. And secure coding. In secure coding, integrating 5G secure coding practices with standard coding libraries to automatically generate memory-safe protocol-compliant patches. And in phase 1 detection. In phase 1, pinpointing conceptual protocol flaws. In this, traditional static analytical tools fail to detect semantic protocol level logic issues in 5G systems. Our COT framework classifies vulnerabilities based on 3 strict dimensions. They are exploitable inputs and security impact and practical exploitability. And second one is repair. It is phase 2. In this, secure coding practices applications. Following detections, our AI engine initiates patch generating by synthesizing 5G specific constants with generic standards CERT and OWASP and automated remediation guidelines. And the repair process injects custom validations checks such a boundary threshold and schema compliance constants for preventing out of bounds index modification, ensuring 3GPP standard protocol integrity. And next, system architecture. In system architecture, we used front-end and back-end and LLM analytical engine. In front-end and back-end is our live implementation establish a dual tier integration pipeline. For interactive web interface, we used the HTML and CSS frameworks for clean source code submission. And backend. We use a robust backend server for designed in Python with Flask manages syntax validations and checks error and coordinate real-time API integrations. And LLM analytic engine. We used the OpenAI modes to execute the precious code parsing and semantic systemizer and secure patch generator. The semantic synthesizer is for intercepts the input arrays, calculates offsets and flags invalidated 5G code, and secure patch generator for reconstruct the vulnerable structures, applying standards boundaries automatically. And we used the Python also for the backend. This is the system architecture we used in project. And next, and the final architecture diagram. In this, there are consist of 3 phases. The first one is LLM based vulnerability detection architecture, and second one is LLM assisted vulnerability repair architecture, and third one is complete LLM security framework architecture. In this, detection and repair. In first one, LLM based vulnerability detection architecture. In this front end interface in web dashboard, we can upload code, and in this front end, in back end server, the code pre-processing and the parse source code and identify functions and identify secure patterns. And the backend server will be the LLM analysis engine will be present. It consists of OpenAI or LLama, and it will be shows the vulnerability detection module. It can be identify the vulnerable lines, classify vulnerability type, and it can be stored in the database in vulnerability reports. And the results will be given in dashboards in database. And next, the LLM analysis will be moves into the second phase 2, the LLM assisted vulnerability repair architecture. In this is front end application. The backend server will be moves into the front end through the LLM engine. The vulnerability detector will be followed by the COT prompting. The LLM will be repaired by Falcon, GPT or LLama, and then the code will be repair module and repair and replace vulnerable code and suggest secure implementation, and now testing module, static analysis and code validations, and it will be stored in the database. Next, phase 3, the complete LLM security. In this framework architecture, detection and repair. In this, the user will be enters the code and login and code and the application server through the LLM. Next, LLM repair engine, it will move into the application server. Here the code will be analysis. It can be analysis the LLM. After that, it will be explain the vulnerable properties, and it will be detect the errors and generate the fixed code, and it will be explain the vulnerable properties and fixed code repaired. It will be stored in the database. It can be seen by the user. This is the final. And the live implementation workflow is, if we enter the user input code, user submit unverified vulnerable 5G source code. Next, it will be moved to the routing, and the Python Flask backend receives the payload sanitizes metadata and COT framing. Next, and prompt construct the analytical layers with defined VPS. Next, LLM engine. It is open AI API processes request and draft patch open options, and next final output. It will be gives the repaid code and custom boundaries and explanation of returns. Next, it is the enhancements over the base paper and our enhanced solution. In base paper baseline, focus strictly on offline manual classification of 5G security vulnerabilities and properties. And enhanced solution for that, developed an end-to-end active web execution sandbox featuring several critical original enhancements. And it will be have integrity framework and dynamic phase module and error fallbacks. These are the changes according to base paper and enhanced solution. And next one is, and the detection performance. LLM assisted COT is 92% vulnerability recall and a standard LLM prompt it is 68 recall. Traditional static tool 45% recall. And then future proofing of 5G. Innovative project impact. This project is successfully introduced as an automated pipeline bridging the gap between cutting edges, generative AI and cellular protocol security. Key accomplishments. Our implementation sets an innovative benchmark by automating the detection and self-healing repair of critical logical flaws, ensuring open source 5G user equipment. Software becomes resilient against complex over-the-air experiments. Okay, now our project implementation is we created a 5G folder, and here the reports.json. Here we enter the rules and datasets rules, and next static. In static the script.js. It will be works at the back end, how to enter the code and how to analyze and how it will be works we seen here. And next this is the app.js, and next is styles.css. It will be shows the website working and the where it will be opens. It will be shows that this is the styles.css. It will be used in the app.js. And this is the index.html. In this the how the code will be enter, how it will be analyzes and how it will be works, and it will be shows here. And in this code how the website will be opens and analyzes the code, how to detect the vulnerable properties, it will be shows here. Next environment, and in this the code a Gemini API key will be used here. And next this is the app.py. In this code how the process will be running at the backside, it will be shows here. And next config.py. In this we used the Gemini API key at the back end to work as the OpenAI to detect the vulnerabilities. And this is the detection.py. In this we can give the some data sets like rules to how the 5G code will be detect the vulnerable properties. We gave some vulnerable properties to this, and it will be analyzes the Gemini API key. And next it is the Gemini API key that was entered into the backend. And next we used the repair.py in this code. We can give the some vulnerable properties according to the base paper VPS1 and VPS2. Some rules will be given to this, and report.py. Now in this click on new terminal. Now we open the app.py, Python app.py. If we enter this, then the website will be opens. Here the show like this LLM assisted vulnerability detection and repair. In this we have to paste the code, and next click on the analysis code button, then it will be generate the analysis result. And here we pasted the code, and it will be get the output. It says that the analysis report, the buffer overflow, and the buffer overflow code due to gets input, and like this it will be give the output and gives the repaired code. And this is about our project.